All right, everyone. We are going to continue where we were on Monday. So we're going to have just a quick um, hey guys. We're going to pick up where we had left off. So just before we jump into just two examples to kind of review um, where we left off on Monday, I want to bring back Monday's notes. And we did talk about throwing an altitude into a right triangle does create three similar right triangles. We know they are similar because they all have right angles. And we have these reflexive angles at the corners that are going to create these acute angle situations that get repeated when we split those other ones up. So that's how that transitive property comes into play. So we then kind of played around with tick marks, we played around with patterns, we played around with just arbitrary numbers that we put into these triangles to kind of make it a little bit more meaningful when we did then match our correspondence. So again, depending upon how we're going to name certain triangles, we want to make sure that however the first one is named, we match the other two accordingly. So that's kind of what our first example is looking at. We then went into how these similar right triangles will then help us with what's called a geometric mean. And when we talked about this geometric mean, we wanted to know, well, what is it? It's a repeated side in two similar triangles, two similar right triangles specifically. It's like reflexive, but they don't correspond. And the sides are always the same length. So that's how it's similar to, no pun intended, similar to reflexive in that it's the same side, it's the same length, it's repeated in our two triangles that have this relationship. But because they're not congruent triangles, they're similar triangles, we end up finding out that they do not correspond. So for instance, we talked about AB is this repeated side. In our green triangle, AB was what ended up in this example being the longer leg. But AB in our pink triangle was actually the hypotenuse. When we looked over here, we can see two colors at BC. Well, again, in our original green triangle, it ended up being the shorter of the two legs, but in our blue triangle, it was the hypotenuse. So same segment, same length, but they don't correspond. And then we saw that this segment had repeated colors, the pink and the blue, but what we also found out is that they were the same length, the same segment, but they don't correspond. In our pink triangle, it ended up being the shorter leg. In our blue triangle, it ended up being our longer leg. So I get that there's lots of shared colors, but it's this idea that this leg doesn't change its length the minute it becomes the hypotenuse. It just doesn't correspond. So when we talk about geometric means, we're talking about repeated segments, repeated sides, the same length, but they do not correspond. So then we started looking at how do we get all of this work that we would have to deal with our proportions. Now, one of the things that I did not do with your class, but in order for this to be a little bit easier, the geometry class, and I will load information to your notes. What I did was I said, well, if we're going to take these similarity statements, this guy right here, I broke it down into three groups. The green and the pink was together, the pink and the blue was together, the green and the blue. And just like in the last chapter, I'm able to create proportionality statements. What we saw were these guys get repeated. These, just like before, are those geometric means that we were talking about. So we talked about having this idea of Depending upon how you wanted to look at it, altitude in the means position, part and part, leg in the means position, but what was it a part of? And that helps for us to solve the missing piece. I was asked a ton to kind of explain where all of it was coming from, and I didn't want to just give you formulas. So this is where it all comes from, our proportionality statements. What do we really do? We cut to this chase. After the cross multiplication, after we actually do our means extremes product theorem, we end up with this idea. Typically, if we were in the classroom right now, I would tell all of you to take out your formula sheets. In your formula sheets, I would tell you to draw this picture exactly the way you see it and write out these formulas exactly the way you see it. And that way you realize that those are actually our altitude on hypotenuse formulas that you would be able to use. You don't have to use the proportions if you don't want to. You can cut to the chase and use these formulas. It'll work every time. And then what we ended up doing is we said, let's look at it a different way, name them completely different letters, even move the C in a different spot. And can we identify which are the geometric means? Again, we also noticed that there was this pattern that they came out of the original right angle. And then we wrote our formula. So we have this idea that you can memorize the formulas this way. You can memorize the formulas. The altitude is the geometric mean of the two parts. The leg is the geometric mean of the hypotenuse and the adjacent part, regardless of which leg. So again, either this way or this way, you will get the same answer every time. With the proportions, you cross multiply. With the formulas, you've already done the cross multiplication. And then we did 2 example problems just to kind of see if we could solve for our variables. We had one where we looked what our x is. X actually is the geometric mean of our adjacent side and the entire hypotenuse. So we either wrote this formula, we showed the cross multiplication, and we filled it in and solved. Over here, we saw that if we're solving for x, x ends up being the geometric mean of the two parts. Issue was we didn't know what one of the parts was. So we ended up having to use our other geometric mean and solve a problem to then plug it back in. So that's kind of where we were on Monday. So before we go any further into today, I want to kind of just give you a look at these 2 problems. And I'm going to give you a second to either write them down or think about them. But if you think you know, for example, 1, any of the triangles, type them in. If you think you know for number 2, type them in. And I'm going to just give a couple seconds and then we will talk. All right, so let's take a look. I see that we've got PNQ and NMQ. So we talked last week about giving ourselves a pattern and keep filling things in. I'll keep looking over here. Don't be shy. When we looked at our pattern, we did talk about, we know that we have a reflexive angle up there. And we know that we have, and I'm going to zoom in a tad bit so you can kind of now see the colors. And we know that we have a reflexive angle down here. What we also talked about is knowing that even if we plugged in arbitrary numbers like 30 and 60, that when we do the right triangle math again, we're going to end up with the same two values here. So if I have a pink angle tick mark here, we know it's going to show up over here. The subtraction isn't going to change just because we changed locations. We know that green tick mark's going to show up over there. And we do know that we have another right angle, even though we don't see it, over there. So following a pattern, if I see PMN, my brain is looking at pink, green, right. So pink, green, right. So I want everything else that I'm going to mention to be pink, green, white, or pink, green, right. So when I go PMN, I'm going to fill in the other one, pink, green, right. So NMQ, and we've got one of them right. Nice job, Landon. When I look at what the other one is, pink, green, right. So PNQ. Probably over the course of the time I've been teaching, that seems to be the easiest way to get those correct. If you've tried any of the no-re questions, you will find that half of them is just revolving around this topic. All right, anybody got anything for the geometric means? Which ones we think the geometric means are? I'm going to give a second to see if anybody can type those in. All right, so let's remember what we talked about our geometric means. I know there's that odd pause because there's also the delay. We want to remember that the geometric mean, these are our repeated segments. In similar right triangles. Same lengths do not correspond. We also talked about the hint is that they all share that right angle vertex endpoint. All right, so we've got the segments that are all going to share this vertex endpoint. So every segment that's going to have an X is going to be one of our geometric means. So when you look at all three of these, that is the easiest way to tell which one is our geometric mean. So when we answer this question, you would have to simply say WX with that segment bar. Don't forget, we could say ZX, and we would have YX. Or, of course, XW, XZ, XY, they're all the same. So which ones are our geometric means? Those are our repeated segments that have the same length, the same position, but they do not correspond. And again, the easiest way to identify where they're at, they share that right angle vertex. All right, so our third example that we're going to look at is, again, where do these come in handy? And again, we could set up our proportions. We could use our formulas, but the only major thing is if we take our right triangle and we put that altitude in there, and then it tells us it wants us to find a missing length. So let's see here. Let's solve for x. So a lot of times what you'll see is you have to do problems within problems in order for us to actually get what we're looking for. So one strategy that I also have said that might make this easier is when we want to solve but we're unsure, I go back to this. I look at that formula. Get over here. I don't care if I'm on or not. Now go. I want to look at these. It's interesting, what you guys don't know is every day she doesn't want anything to do with me until I start talking to you guys, and then she comes in and asks for something. So I've had about 6 weeks of enough. That was, she needed to put earrings in today. So we're going to make sure that she understands that was inappropriate to interrupt me at work. So we are talking about our geometric means. We have our formulas. And now what we want to look at is, how can I make that look the same? So I'm going to fill in variables. I don't really care which variables we use. We could throw a y in here just because one of our initial formulas has a y. We can throw b in here because one of our initial formulas had a b, and we can put an h here. So one of the strategies would be is to just write all the formulas out. So I can see that I have my 3 geometric means. They all come out of that right angle, 8. Now what we have labeled as h and what we have labeled as b. So I know, according to my formulas, I'm allowed to square because all of our geometric means are our repeated sides. We know that when we put them in our proportions that we cross multiply, and we multiply something by itself. Leg times leg is multiplied by itself. Altitude times altitude is multiplied by itself. So they all get squared when we do our means extremes product theorem. We also know that adjacent part times the hypotenuse is what we're looking for, or adjacent part times the hypotenuse or part times part? Well, again, if I'm only wanting to solve for x, I only need these two formulas, but I don't have enough information. So that does mean I need to solve for this first, which again, if you saw that right off the bat, maybe this strategy isn't necessary. If you didn't see that right off the bat, then maybe that is a strategy that will work very well for you. So I know that this is going to be 64 equals 10y. And when we divide by 10, we end up with 6.4, which would be 6 2/5. Again, you know as well as I do that all of our standardized tests, we have concentrated on this all year, fractions, 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 and then we were holding ourselves accountable for fractions, and we forgot about fractions. So don't forget, use your calculator if that is something that is, without a doubt, a necessity. So I could, right here, put in 6 2/5, and I could subtract to find x. Now, here's something else to consider. I can continue this pattern and continue to use these, but did anybody else recognize that they were able to find b a different way? So I'm going to ask, did anybody notice what b could be without having to go through all of these steps if we didn't want to? Good. We have our Pythagorean triple. If you take a look here, 8 and 10, this is actually 4, 5. We just multiplied it by 2. We increased it by 2. So whether we wanted to do a Pythagorean theorem or recognize this is actually a 3, 4, 5 right triangle, this is 6. So yeah, we could have noticed that it was a Pythagorean triple, 3, 4, 5, or we could just do the Pythagorean theorem. And now we know what b is. So I could plug 6 in and square it because we did the Pythagorean theorem, and we end up with 36 equals 10x. So x would end up being 3.6, but we could put 3 3/5. You would have absolutely got the exact same information had you subtracted and plugged it in that way. So you can look here that if we didn't do it this way and subtract from 10 and get that 3 3/5, you would have found it the exact same way if you noticed that you had the Pythagorean theorem. So either way, we had to do a problem before we got to the answer, whether it was the Pythagorean theorem or our altitude on hypotenuse, but we just have another tool in our toolbox to do so. So with that being said, that is the end of at least how these formulas and these proportions can be used. So I wanted to again go over the 3 things that we looked at last on Monday. I do want to show you 2 very easy things. And it's questions that are simply what, forgot to write in H, what is the geometric mean of, let's start with 4 and 9. So when you think about, again, what a geometric mean is, we have these proportions where the mean's position was repeated. So whether it's leg, leg, altitude, altitude, x, x. The mean position was the repeated segment, the repeated side, the repeated length. They just didn't correspond. So they're not in the same position in our fraction. If we look at where the 4 and 9, those are our extremes. Whether it's 4 and 9 on the bottom or 9 and 4, doesn't matter, but they're in the extremes position. So what we find out is when we do this cross multiplication, x squared equals 4 times 9, we end up with x squared equals 36. Well, in order to solve, we have to now take the square root. So we end up with x is plus or minus 6. Now, you need to be careful because we know that algebraically that's plus or minus 6. You need to account for both. However, remember that a geometric mean is an actual length. So don't be surprised if now 6 is just your only answer, because a geometric mean is an actual segment. So if you are asked these questions and initially you put in 6 and it's like, nope, it's not right, remember that it could just be looking for the algebraic answer. So we've talked about plus or minus before. Now, please don't forget that I could ask you something that isn't as nice and neat as 4 and 9. Um, 12 and 28. So again, we would remember that the geometric mean is that repeated spot. We would end up with our other two numbers. And honestly, if you cut to the chase and you simply did the x squared equals 12 times 28, or even in your calculator just went as far as to say, okay, x squared is 336, and I know that x is going to be the square root of 336, I would continue to then rationalize. And if you have to, I don't know if you were able to hear me tippy-tapping on my calculator, but I took that 336 and I divided it by 2, and I divided it by 2, and I divided it by 2 again, and I divided it by 2 again, and what you end up with is 16 times 21 is 336. So this is actually the square root of 16 times the square root of 21. And we know that the factors of 21 are 3 and 7, so we're not going to be able to take the square root of something with prime number factors. But we are able to take the square root of 16. So our simplest radical form would be plus or minus 4 radical 21. And again, because a geometric mean is technically a length, you would end up with 4 radical 21. Again, you have our geometric mean, our actual length, or you have it algebraically correct because you know that that is possible either way. Now, to finish up, we did purposely bring in this idea of the Pythagorean theorem. With that being said, I wanted to make sure that we did have an example right away from the Pythagorean theorem, because your other no reassignments is all Pythagorean theorem information. And I went through and I looked at each and every one of the questions 2 times just to see what the variety was. And I'm really excited that everything that we have done, both on your midterm exam as well as all year, there is nothing new in that section. So I want to remind you that we have our Pythagorean theorem questions. So with our Pythagorean theorem, you had a squared plus b squared if they were the same. So again, if they were equal, we ended up with a right triangle. We had if a squared plus b squared was greater than c squared, we had that it was an acute triangle. And a squared plus b squared, if it was less than c squared, we had that it was an obtuse triangle. And part of the questions are going to have you going back and either what kind of triangle, or it's going to ask you, is it a right triangle? Well, is it means do they equal each other? Does this side added together equal that side? If not, we should be able to tell if it is obtuse or acute. We will meet Friday just so that you can ask any questions on the no reassignments. Please make sure that you come prepared or screenshot for me all of your questions, and then I will be prepared on Friday so that we can talk about it. We are going to Zoom on Friday, and it will be at our normal time at 10 a.m. So please check Google Classroom for that. I'm going to pause. There'll be the odd, awkward silence. I want to know if you have any questions at this point. And I'm going to check my email as I wait to see if anything shows up in the chat. And if you find that you don't have any questions, again, please remember that you can email me all questions. And some of you were able to find out that when we loaded some of our tests and assignments, and I'm not sure how or why or what happened, but some of us loaded our ENC pages to different days that the assignment was given, or didn't email it to me and loaded it someplace in Google Classroom. I will tell you that I went through every student in honors geometry individually to see if they handed in anything at a different assignment's date or location. I went through all of my emails. I made sure that everybody was up to date, but just please keep in mind in the future, if you load something and you're unsure if I've seen it, toss me a message too, just so that it goes directly to wherever you have loaded it. And that way you don't have to worry. And like I told a couple, I thanked you guys, and that was truthful. That was very sincere. It is always, especially now, don't ever be afraid to tell your teachers, hey, I did this. I just want to make sure you found it. It is always good to put yourselves first when it comes like this. And if somebody's feelings are hurt, that's on them, not you. You guys did the right thing, and I do appreciate it because I don't want to miss anything knowing that we can't have a face-to-face conversation. So all the grades are updated. You guys have definitely made me feel pretty good about how focused you are. Continue to stay focused. We have things to take care of next year, and we want to make sure that we're there for each other, but we're also making sure that we are focused for ourselves. This isn't forever. We have to make sure we stay at the top of our game. So if you have any questions, email me, and I will get back to you ASAP. Please check Google Classroom for our Zoom information for Friday, and I will talk to you all then. Have a great day.